Hello everyone, good morning. Today we will dive into a topic that every backend engineer eventually faces in his career. RabbitMQ versus Kafka. Why they are, what they are, how they differ, and when you should choose one over the other. Before we even get into the message queues, let's start with a simple question. Why do we need a message queue at all? So why message queue exists? Imagine you have two services, say order service and inventory service, talking to each other through a simple HTTP call. That works fine until things go wrong. Maybe assume the downstream service is slow, or it is down, or suddenly you're getting a millions of orders in a burst, or your Kubernetes pod that you plan to scale doesn't scaling at the same pace, or you don't even have a control of the downstream services to scale, or in an instance where the retry logic is something that you want to control without doing any duplicate work, or you want to protect the main service from failure because of the other downstream services down or any other subsequent failures. You don't want to have the main service as a continuous failures. So you have the task that should happen later without blocking the user. HTTP simply cannot handle these situations gracefully. This is where message queues comes into rescue. The beauty about the queue is it can absorb any amount of load your application throws at it. It stores the request, guarantees delivery, and let downstream services process work at their own pace. The flow looks like this. The order service sends a request. The queue accepts it, immediately responds success back. The inventory service processes a message later at its own pace. This decouple is the foundation of both RabbitMQ and Kafka. Both systems follow the same pattern. Producer sends a message, broker or queue stores or routes a message, and consumer processes a message. But how do they do this is completely different. And that's what determines which one you should use in your application. RabbitMQ. RabbitMQ follows the classic message queue architecture. Producer, exchange, queue, consumer. Think of exchange like a post office. Based upon the routing rules you configure, RabbitMQ decides which queue the message belongs to. RabbitMQ broker does a heavy lifting here. It handles routing, means it evaluates the routing key, and based upon the rules that you set, it decides which queue the message should be receiving to. And retries. If a consumer fails for whatever reason, RabbitMQ redelivers a message. QoS fetch. So controls how many messages a consumer can receive before acknowledging them. Most teams set the prefetch to 1. And the delivery tracking stores messages, deliver them, track the acknowledgement, and NAC as well. And dead letter queue. If the message is not delivered, then the message automatically goes into DL queues, dead letter queues. And the ordering. RabbitMQ maintains a strict ordering per queues. From a consumer perspective, consumer thinks that, hey, all you need to do is subscribe to your queue, process messages, send acknowledgement, and you're done. The broker handles everything else. The use case is pretty simple and straightforward. The use case is perfect for a task-oriented work. Sending email, process payments, resizing images, background jobs, anything that needs to be done once and forgotten is the best use case for RabbitMQ. Instagram uses RabbitMQ for photo processing today. Reddit uses it for comments and karma scoring. Now let's get into the Kafka. Kafka works like a distributed log, where every new message is simply written to the log. And reading messages doesn't remove the message from the topic. The data stays in the log for as long as the retention policy allows it. You can set the retention to be hours, weeks, or even forever. Consumer moves through the log at their own pace. Each consumer keeps track at the position it last read, and it is called as offset. If a consumer crashes, it just looks up its saved offset and continues from them. And because the log is persistent, consumer can jump back and reprocess old messages whenever needed. RabbitMQ and Kafka. If I put in a simple words, RabbitMQ is a smart broker, simple consumer, and Kafka is a smart consumer and simple broker. This means that RabbitMQ does the most hard work. It decides where each message should go, keeps track of messages were delivered, and tries again if something fails. The consumer don't need to think much. They just get a message, do the job, and say, I'm done. And RabbitMQ is a message broker. Messages move through it and then disappear after they are used. But on the other side, Kafka is mostly a simple message store. Messages store in the order it receives. It doesn't try to route them or handle retries. Instead, the consumer are the ones that chooses what messages need to read next. They remember their own place in the list and can move forward or backward whenever they need. This means that many consumers can read the same message even they are doing the different jobs. For example, your analytics team can look at the events and your notification teams can look at the same events too. If you build a new service months later, it still reads all the old messages that happened from the beginning and catch up. Kafka is a lock. Messages stays inside it for a long time and you can read them again whenever you want. Now let's get into the technical differences between the two, Kafka and RabbitMQ. Right? So RabbitMQ, the first thing and foremost we'll look into is ordering guarantees. RabbitMQ keeps messages in a simple order they were sent. If only one consumer is reading, the order is perfect. If many consumers read at the same time, they work in parallel, so order can be mixed up to go faster. So if producer sends 1, 2, 3, it goes straight into the queue and the consumer reads in the same order. Whereas the producer sending the same like 1, 2, 3, 4 goes into the queue. If 2 consumer reading, the order can be mixed up. Whereas Kafka works a little different. Kafka also provides ordering guarantees by splitting topics into a group called partitions. Inside each partition, the order is kept. Across different partitions, the order is not guaranteed. You choose which partition a message goes to by picking the partition key. So the consumer message stays in order, but no global ordering. Throughput and latency. RabbitMQ can handle messages about 4,000 to 10,000 messages per second, whereas Kafka can handle about 1 million messages per second. It is fast for small workloads, usually about 1 to 5 milliseconds is what it takes, whereas here Kafka is about 100 times faster. It usually takes about 5 to 50 milliseconds because consumer messages are pulled in batches. That's why it takes 5 to 50 milliseconds. RabbitMQ does a lot of work for every message, like tracking delivery, message acknowledgement, routing. When a load increases, throughput decreases, or it slows down. Whereas a Kafka, on the other side, the broker does a very little work. It just writes messages to the sequential log. This makes Kafka stay fast even with the system stays busier. Coming to delivery guarantees, sometimes the consumer fails to process a message. To reprocess them, we have 3 different solutions that these queues provide. The commonality between both is at most once and at least once. At most once, that means it doesn't do a retry. The message might be lost forever. We just send once. If it delivers. If it does not, it doesn't bother. Whereas at least once keeps retry until you get acknowledgement. The same thing here, but it provides one extra functionality which is exactly once, but there is a little nuances about it. It only works if the sending and receiving message stays within the same cluster. If it is different, our messages goes writing into a database, calling at the service, you lose exact once behavior and falls back to the at least once. So most apps still need to handle the duplicates properly. Ease of running. RabbitMQ is easy to run. because it is a simple one program executable file which has everything you need. It has simple cluster, it has a built-in UI within the same file, and small team can use it simple. They can run it without any trouble. Whereas Kafka on the other side, it is a little harder. The older versions needed Zookeeper, the new version used Raft, which is simpler, but Kafka still have many moving parts like a partition, rebalancing, broker failures, consumer grouping, and topic settings. Many teams use manage Kafka services because of all this headaches. It uses simple Confluent Cloud, Amazon MSK, and Azure Event Hubs to avoid the hard parts. Like I said earlier, when to use RabbitMQ versus Kafka, if your application is needing a simple background jobs or task queues, sending emails, processing payments, resizing images, smart routing, or very small delay, simple setup, you can go with RabbitMQ. Instead, if your application is looking for many systems reading the same events like analytics, fraud detection, billing, audit logs, replay old messages is a big thing that you need, and huge scale, millions of events per second, and long-term history of events, everything that happened is something that you're concerned about, then going to Kafka might be a better solution. The real-world use cases that are using these two were Instagram uses RabbitMQ for photo processing, Reddit uses it for comments and karma scores, whereas Netflix uses Kafka for recommendation and billing, Uber uses it for real-time pricing and fraud detection, and LinkedIn uses for feed and messaging. All in all, RabbitMQ is great for tasks that need to be done once and then forgotten. Kafka is great for the events that many systems need to read, replay, and store for a long time. Some companies use both, Kafka for the main event streams, RabbitMQ for the background jobs triggered by those events. Thanks for watching. If you found this breakdown helpful, hit like, subscribe, and drop a comment.